Good morning, calculus. So today what we're doing is more with definite integrals, or like more with integration by parts, but we're doing definite integrals with integration by parts. So really, it's just going to be the same sort of thing, except once we do integrate our integral, we just want to calculate the definite integral with certain values. So looking at this first problem here, I have the integral from 0 to 1 of 6x e to the 3x dx. And if I think back to that acronym, that LIATE, I have my two functions here. I have this 6x, which is going to be algebraic, and I have this e to the 3x, which is exponential. So algebraic, the a, comes before the e, the exponential. So I'm going to be using the 6x as my u here. So I'm going to say u equals 6x, which means dv is everything else. It's the e to the 3x dx. So from here, just a second. Sorry, trying to find where I put my handwritten notes, just so I can follow along, make sure I'm doing the right things. So from here, I have du is just going to be 6dx. And then v would be 1/3 e to the 3x. So remember, we want uv minus the integral of v du. So it would be 6x times 1/3 e to the 3x, because that's u times v, minus the integral of v du. So 1/3 e to the 3x du, so times 6 dx. And let's see. Oh, this is a definite integral. So I'm going to go from 0 to 1 there. And I will be calculating this from 0 to 1 as well. I just don't need to worry about it yet. So let's see. I have this 6 times that 1/3 is going to be 2. So 2x e to the 3x minus the integral. Again, I have 6 times 1/3, and I can pull that outside the integral. So I can have 2 e to the 3x left inside dx, 0 to 1. And the integral of e to the 3x, well, we already calculated that, it's 1/3 e to the 3x. So I'm going to have 2x e to the 3x minus, and this was all negative 2 times 1/3 e to the 3x, so minus 2/3 e to the 3x. I'm evaluating this entire thing from 0 to 1. So I plug in 1, let's see, 2 times 1 e to the 3, so that would just be 2 e to the 3rd. Minus 2/3 e to the 3rd. Minus, then I'm going to plug in 0. Well, I know that that x there is going to turn into 0, so that's going to turn into nothing. So I have 0 minus, and then 3 times 0 is 0. E to the 0 is 1, so minus 2/3, or negative 2/3. Or wait, no, it's just 0 minus 2/3, my bad. Yeah, 0 minus 2/3. Oh, I need to give myself more room. Oh. Shrink it down a little bit. Okay, there we go. So let's see, this over here, I have 2 e to the 3rd minus 2/3 e to the 3rd is going to become 4/3 e to the 3rd, because that 2 is like 6/3 minus 2/3 is 4/3. So I have 4/3 e to the third power. And then I have minus -2/3 or plus 2/3. And this would be my final answer. That is how I would calculate the definite integral using integration by parts. 4/3 e to the third plus 2/3. And then we have this next one here, which is the integral from 0 to pi over 2 of x times the sine of x. Let's see, what am I going to do here? I have x and sine of x are my two functions here. X is algebraic, sine is trigonometric. So algebraic comes before trigonometric, meaning my u here is going to be that x, whereas the dv is the sine of x dx. So let's see. If u is x, then du is dx. And then if, if dv is sine of x dx, then v is going to be negative cosine of x. So I'm going to do u times v, so that would be x times negative cosine of x. So let's say negative x cosine of x minus the integral from 0 to pi over 2 of v du. So that would just be negative cosine of x dx, because du is dx. And since I have this negative inside the integral, I'm just going to take that outside and turn that into plus this integral. So now I just want to integrate that cosine of x, which is going to become sine of x. So I'm going to have negative x times the cosine of x plus the sine of x, which is the integral of that cosine of x dx, from 0 to pi over 2. So that one wasn't too bad. And let's see, I plug in pi over 2. Negative pi over 2 times the cosine of pi over 2 is 0. And then plus the sine of pi over 2, so plus 1, minus, so I have negative 0 times the cosine of 0, so negative 0 times 1, plus the sine of 0, which is 0. So that's just, this entire side here is 0. This is 0 plus 1, meaning the final answer is just 1. It's just 1 minus 0. So that's kind of just the gist of what we're doing today. And we have these area and volume problems too. And now that I have worked through these volume problems before recording this video, I realize why some of you were going wrong when you tried to use the shell method to calculate the volume, because you needed to do integration by parts, but you weren't. So yeah. Anyways, area, this first one, find the area bounded by f of x equals the natural log of x equals e, and the x-axis. So if I sketch a little graph of that, here are my axes. Let's see, x equals e is going to be about there. And then the natural log of x is going to look something like this. And it crosses the x-axis at 1 to e. So I want to calculate this area here. So that would just be the integral from 1 to e of the natural log of x dx. So the integral from 1 to e of the natural log of x dx. So let's see. When we only have one function inside the integral, then our other function is 1, which is algebraic. And natural log is logarithmic. Logarithmic comes before algebraic in that acronym, so that natural log is going to be my u here. So u equals ln of x, and dv equals 1 dx. So du is going to be 1 over x dx, and v is going to be x. So same thing as last time. I want u times v, so natural log of x times x. I'll say x times ln of x, minus the integral of v du. So v is x, du is 1 over x dx. So that's just x over x dx from 1 to e. Clearly this x over x is just 1. And the integral of 1 is x. So I'm going to have x times the natural log of x minus x, and I'm evaluating this from 1 to e. So when I plug in e, I have e times 1, because the natural log of e is 1, minus e, minus 1 times natural log of 1, which is 0. So 1 times 0, minus 1. So I have e minus e is 0. 0 minus 1 is negative 1. 0 minus negative 1 is 1. So that's my final answer here. The area bounded by this curve is 1. So on number 13, I'm going to do something similar, but this one is volume. And I'm going to use my shell method here. And I know that Ms. Gilbert taught you about the shell method. I did the disk method, and this one would be actually kind of hard to calculate using the disk method because we're revolving it about the y-axis. So I'll show why it's going to be hard to do that. The function is e to the x, so something like that. X equals 1. And the x-axis, and it's the first quadrant region, so it's all this. So the reason it would be hard to calculate this if I tried to use the disk method is because the disk method, remember, we would have to change everything in terms of x instead of in terms of y. We would have to say like x equals the natural log of y instead of y equals e to the x. And then I would also have to change my my limits here, because that goes from 0 to e. But this distance here isn't actually determined by this function of the natural log, or e to the x. That distance there is just filled in the whole way. It's only this distance here that is affected by that part. So you would have to do two separate integrals if I were doing this with the disk method. But using the shell method, this is going to work without doing two separate integrals. And remember, the shell method is going to be 2 pi times the integral of x times whatever your function is. So 2 pi times the integral, and our limits on x are 0 to 1. So the integral from 0 to 1 of x times the function, which is e to the x, dx. So I have x times e to the x, that's an algebraic and an exponential. Algebraic comes first in my acronym, so the u is going to be x here, whereas dv is going to be e to the x dx. So if u is x, then du is dx. And if dv is e to the x, then v is e to the x. So I'm going to do, well, I have 2 pi, first of all, times u times v, so x times e to the x, minus the integral of v du. So the integral from 0 to 1 of v du. Well, that's pretty simple, because I can just, the integral of e to the x is e to the x. So I have x times e to the x minus e to the x, and I'm evaluating this from 0 to 1, and also multiplying it by 2 pi. So let's see, I plug in 1, so I have 1 times e minus e, so that would just be e minus e, right? Yeah. Minus, and then I plug in 0, that would be 0 minus 1. Looks pretty familiar. But e minus e is 0. 0 minus 1 is negative 1. Oh, I forgot my 2 pi. So I know that e minus 0 minus 1 is just going to be 1 times 2 pi is going to be 2 pi as my final answer. So the volume of this region when it's revolved about the y-axis is going to be 2 pi. And let's look at the final one here. So find the volume of the region bounded by f of x equals natural log of x equals e, and the x-axis when it is revolved about the y-axis. So kind of the same thing here, and that is the same function that we had in number 12. So I know that it's going to look like this. And we're revolving that about the y-axis, so it's another vertical revolution, and I'm once again going to be using the shell method here. If we use the disk method on this one, it would work. Actually, we would use the Washart method on this one, but it would work, and it would get us the right answer. And honestly, I think it would be easier to use the Washart method here, but we're going to use our integration by parts with the shell method. So this is the integral from 1 to e of, what is that? It's x times the function, the natural log of x, dx for the shell method. So I have an algebraic and a logarithmic. So logarithmic comes first, which means u equals the natural log of x. dv is x dx. So du is 1 over x dx. And v would be 1/2 x squared. I'm going to have u times v, or 2 pi first, times u times v. So that would be 1/2 x squared natural log of x minus the integral of v du. So 1/2 x squared times 1 over x dx. I'm going to take this 1/2 and pull it outside the integral. I don't think we have any opposition to that. And then I have x squared over x, which is just x times x divided by x. So the answer would just be x inside the integral. So I have this negative 1/2 integral of just x dx. And I know that the integral of x, well, I already took that. It's 1/2 x squared. So I'm going to have negative 1/2 times 1/2 x squared. Negative 1/2 times 1/2 is negative 1/4. Ooh, dang it. I keep using that scissor tool instead of the eraser. So negative 1/4 x squared. And then I had this other part that I had to add in, that 1/2 x squared times the natural log of x. And I can't forget that 2 pi. And I'm evaluating this from 1 to e. So if I plug in e, I'm going to have, let's see, 1/2 e squared times the natural log of e, so 1. So I'd have 1/2 e squared minus 1/4 e squared. And I'm subtracting. I plug in 1. The natural log of 1 is 0. I know that this entire first term is going to turn into 0. And then I have 1 squared is 1 times 1/4. So I have 0 minus 1/4. Can't forget my 2 pi. And let's see, 1/2 e squared minus 1/4 e squared is going to be positive 1/4 e squared plus 1/4, because it's minus negative 1/4. So I have 1/4 e squared plus 1/4, the entire thing times 2 pi. And I'm just going to leave my answer exactly like this. I guess I could technically distribute the 2 at least and say it's pi times 1/2 e squared plus 1/2, but this is simple enough for me. That answer works, and that is what I would say the volume of this solid would be if I take that and revolve it. Now today's assignment, I know it's long. Again, I got these problems from Ms. Gilbert. She left me with I guess like a unit map almost of just, here's the assignments I want them to do on this day. She didn't really give me anything else. I literally just have, it's 1 page and it says, day 2, do this, this, and this. So I'm making these notes on my own. I have the problems that I was able to find online. It was hard to find them online. But these last 6 are all definite integrals, but the first 11 are all practice with indefinite integrals with integration by parts. Let me see, because I know some of them, I'll help you out. I know some of them you're going to need the tabular method or the cyclic method that we were doing yesterday. So numbers 8 and 9 use the cycle method. So 8 and 9, you'll need the cycle method. And then I use the table method for numbers 2 and 3. So I use the table method for these two. So yeah, if you need any help with any of these, feel free to just message me on Schoology, let me know. Oh, and one other thing is that Jay Kong brought to my attention yesterday that Ms. Gilbert used to post answer keys for you guys. I didn't know that. So I will continue to post answer keys for you guys. So you can check your work. You don't have to pop into my office hours to see if you got the right thing. But as long as you show your work, you'll be good. Show your work and show how you would get to that answer. So I will post answer keys to the past 2 days' assignments as well, and this one. And I have asked Dylan Hildebrand to make answer keys for all the Chapter 7 stuff. So there's that. Other than that, I'll see you guys tomorrow.